Hello, good morning, everyone. Hello, am I audible?
Yes, sir, you're audible, sir. Good morning.
Yeah, thank you. Good morning. We'll wait for a couple of minutes, okay? Then we'll start.
Hello.
Hello. Yes, Abhinav.
Hello. Good morning, sir. You are
Good
audible.
morning. Okay, thank you. Okay, I guess we can start the session. So, good morning, everyone. So, today we'll discuss the week 9 content. Okay. So, how many of you have watched the week 9 lecture? Can you please raise your hand?
Not yet done, sir.
Oh, okay. No issue. So,
Complete, sir.
okay. Asha. No issue. So, today I will just discuss the concept and we'll solve few questions also, right? Based on that. So let me share my screen. So is my screen is visible?
Yes,
Yes,
sir.
it's visible.
So in the week 9, we'll be discussing first the maxima and minima. Okay. Now let us recall the content that we have discussed in the earlier week. Say suppose this is my graph, this is my x-axis, this is my y-axis, and say this is my graph. Okay. So I can say from this interval to between this interval, my graph is decreasing, right? From this interval to this interval, I can clearly see, like this is a point. My graph is increasing, right? Now, so this point what we call this point? Yes, anyone? We have discussed this last session. What are those points? Where the
Critical
graph
point.
is, I'm
Turning
sorry.
points.
Yeah,
Turning
yeah,
points
right.
or critical point.
Yeah. So the point at which whether our curve is increasing and after which the curve is decreasing or vice versa, that particular point we call as a turning point, right? Here also you can see in this part our graph is decreasing first, right? Here from this to this, and now again we are increasing, right? From this to this. So this is also my turning point, and here then it is decreasing, right? So this is my basic graph. So by looking at the graph, I can see there are 1, 2, 3, 4 turning points, right? So can I say like by looking at this graph only, at what particular value, so at what particular point my value will be maximum or minimum by just looking at the graph only.
Yes, sir, we can
So if
see.
I, yeah, so if I just take this interval, this from, so this is A to this is B, okay? So from A to B, so say this is my M and this is my N. So at what point my graph is having the maximum value, minimum value from between A to B? Is anyone?
At M point, the graph is minimum, and at
So you
N
can clearly
point,
see that, yeah. So at the M point, our graph is minimum value. At the N point, we have the graph is maximum value, right? So we can say that this basically the point M and N belongs to A and B, right? Between A and B, right? And between for this M and N, my particular graph is achieving the maximum or minimum value. Okay. So this is how that we have discussed in the earlier week. So now, what is the concept of maxima and minima? It is local maxima and local minima. Okay. So between the my domain, at what particular point my graph is achieving maximum and minimum value? So at what point that is basically a maxima and minima of that particular curve, right? So as we know, these all are the turning points, right? These are the turning points. So what if I draw a tangent here? The tangent will be horizontal at this point, right? Hello, right? So if my tangent is horizontal, then what I can say about this particular line? Is anyone?
The slope here will be 0.
Yeah, so the slope will be 0, right? So in the last lecture, we have discussed the equation of a tangent. Like suppose if we have a curve f of x and we want to find out the equation of a tangent at point A, right? So we have discussed that equation, that is y equals to f dash of A x minus A plus f of A, right? This is the equation of a tangent, right? But if we see our particular point, at this particular point, our slope is 0, means our f dash of A is 0, right? Hello, are you getting it what I'm trying to say? At this
Yes, sir.
particular point where my slope is 0, that is turning point, where the tangent is horizontal, I can say f dash of A is 0, right? A means, say suppose this is A. So at this particular point, my f dash of A is 0, right? Now this particular point A is called as the critical point, where my this f dash of A will become 0. So that this particular point is known as the critical point, right? Now here every turning point is a critical point. This is also a critical point. This is also my critical point. These are all my critical point. Okay. And how to find out the critical point? Say this is my f of x. Now just simply differentiate f of x, okay, and equate it to 0. And the root of this particular equation, the root of f of x equals to 0, sorry, f dash of equals to 0 will be my critical points, right? So whenever we want to find out a critical point, just differentiate the curve and find out its roots. Okay. So in that particular root will be the critical point, right? This is one of the thing. Or it may be possible, even if it is not differential, then still it can be a critical point at some point, right? So even if the function is not continuous, but it can have that critical point at that particular point. So point A is a critical point of a function when f dash of a equals to 0, or if either it is not differentiable at a, still it will have the critical point. So you have to see. But the first thing is, if you are given any curve f of x, simply differentiate it and equate it to 0, right? So the roots of this particular equation will be my critical points, right? So, okay. So any doubt till now? How to
Sir,
find out the
you
critical points?
sir, you
Yes.
said if a function is not differentiable, that means suppose if we occur a case where the function is not differentiable, that means we will have to apply the L'Hopital rule or something like that.
No, no. So suppose I have this particular function. So this is my point A, and again this point. So my function is breaking here, right?
Right,
So my function is not continuous here.
right. So it is not
It
differentiable
is
here.
differentiable also, right? But still, at this particular point, it can attain the maximum value. That is, it can be critical point.
Okay, okay,
Yeah, we have to see that. That will be a piecewise function that we'll discuss in one of the activity question. We'll see that.
okay.
Okay. Yeah. So
And
that is
in
also
one of the lecture, professor, the instructor used a word called saddle point. Is there a difference
yeah.
between critical point and saddle point, or both
Yes,
are
yes. I
same?
will. No, no, I will come to that. Yeah.
Okay.
So critical point you understand, right? How to find out? Just
It,
differentiate the f of x and equate it to 0. So whatever the root of this particular equation, that will be my critical point, right?
can we say that a critical point is another name of turning point?
Yes, yes. All the yes, yes. You can say that. Like every turning point is a critical point.
Okay.
So every turning point is a critical point. Okay.
Sir,
So
vice
now you,
versa is also true. I mean, like every critical point is a turning point.
every critical point is turning point. No, that we have to see. So there are, that is the concept of saddle point here, right? It is something saddle point. Now saddle point is also critical point. Okay, it is also a critical point. But at this point, at this point, my function will not attain. Function will not reach any local maximum or minimum value. It will not attain any maxima or local minima. So saddle point is that critical point at which there will be no maxima or minima. So if why we are finding out this critical point? So at this particular point, so you can see there is maxima or minima here, right? It can occur maxima, either maxima or minima. But saddle points are those points where there will not be any local maxima or local minima, right? So this is one of the case. Like say for example, I have given this graph, so I can clearly see that okay, these are my turning points, right? These are my critical points, and I can clearly see that this is my minima, this is my maxima, this is my local minima, this is my local maxima, right? So I can see it clearly. But what if I have given any function, right? That is f of x. I don't have the graph for that. So in that case, what we have to apply? We have to apply the second derivative test. So what is the second derivative test? Let's see. So if the graph is given to us, we can directly see, right? Which are the my critical points, which are the turning points, and this turning point where whether will my it will achieve the maximum or minimum value, right? That we can see. Okay. So any doubt till now?
Okay.
Okay. So discussion. Okay. Now, suppose I have given f of x, then how to see whether how many critical points are there and at what point whether my graph will have a maximum or minimum value or have local or minimum local maxima. So for that, what we have to do, just differentiate the f of x, right? Equate it to 0. And what are the roots of f of x? So roots of f dash of x. So that will be my critical point, right? Now say A is that particular point where I am getting f dash of A equals to 0. That is f dash of A equals to 0. I am getting at this particular point. This is the one of the root of this particular equation. Now what we have to do, just differentiate once more this particular expression, that second derivative test, f double dash of x, and just put this value of A here. So f double dash of A is greater than 0, then I can say at this particular point A, so at point A, it will be local minima. So if double dash of A is greater than 0, at this particular point, it will be local minima. But if double dash of A is less than 0, that is say negative, and here it is positive, then I can say at this particular point of A, it will have the local maxima value, right? And if by putting f double dash of A, we are getting 0, then we can say it is a saddle point, right? Now this is the saddle point. There is no maxima and minima, right? So this is the step that you have to follow. If given any function f of x, just differentiate it, equate to 0, find out the root of this particular equation. The root will be the critical points, right? Now just differentiate once again, second derivative test. Just put those critical point here. Okay, if it is greater than 0, that is positive. And at this particular point, we will have the local minima. Then put f dash of A. If it is negative, then at this particular point A, we will have local maxima. And if it is coming equal to 0, then it is the saddle point. There is no maxima and minima. Okay. So this is how we find out whether we are like at what point we have local maxima or minima, right? So let me take one question. Okay, any doubt in this part? This is second derivative test. Just remember this thing, these steps. Yeah. Let me discuss with one of the question. Okay. Now just looking at this graph, tell me which of the following options is true. So this graph is like this. This graph. Okay. So tell me how many turning points are here?
2.
3.
On
2.
turning points.
3. 3.
This is also, this is my one turning point, this is my second turning point, this is my third turning
4.
point, and this is my fourth turning point, right? So there are 4 turning points in this graph. Now at what point, like how many points we are getting local maximum, local minima? Just looking at this graph only.
2 local minimum and 2 local.
Yeah. So number of local maxima of the function f of x is 2. So this one is correct, right? Local minima of function is 3. No, this is not correct. So we have 2 local maxima and 2 local minima, right? So f of x as a local minimum at the origin, no. F of x as local maximum at the origin, this is also not correct, right? So local minimum is at this particular point, right? This is my local minimum, and local maximum will be at this particular point, right? So say suppose this is B and this is A. So A will be my local minimum point, and at B it will be my local maximum point, right? Any doubt anyone in this question? Just looking at this graph, we can directly tell, right?
No doubt.
So now this is the f of x. Now here we do have the equation of f of x, right? This is the equation of f of x. Now just find out how many critical points are there and which are those critical points. How to find out the critical point? Yes, anyone? Just differentiate f
Differentiate
of
and find
x.
the roots.
Yeah, equals to 0. Yeah. So just differentiate it and tell me how many critical points are there. So what is the differentiation of this? Yes, anyone? F dash of x?
Yes, so 1 minute.
Okay, yeah. Let's try to solve it.
The 2x cube minus 13x square plus 22x minus 8.
Okay. So let's differentiate this term. So what will be 4x cubed by 2, right? Now derivative of x cube 3 will come down and it is x square, right? So 3 into 13 x square divided by 3 plus 22x minus 8, right? So this 2 will get here, this 3 will get cancelled. What I will get? 2x cube minus 13x square plus 22x minus 8, right? So this is my f dash of x. Now if I want to find out the critical points, just equate it to 0. So how many root it will have, this equation?
The 3.
Yeah, so at most it will have 3. I can say the number of critical points are 3 here, right? And what are those critical points? We have to find out the root of this particular equation. So how to find out the root? Here we have given the option, so you can just simply try to put the value and just see if it is satisfying or not. This is one of the case. Or just find out the one root by trial and error method, and then you can simply divide it this equation, right? So you will get the other two roots also. So just try to put x equals to 4, x equals to 1, x equals to 2, whether we are getting 0 or not, at what point we are getting 0. Those will be my critical points.
Sir, 2 and 4 it is fine.
For 2 and 4, it is satisfying. Hello? Yes?
Yes, sir.
Yeah. So for 2 and 4, it is satisfying, right?
Yes.
Suppose I have given this, I have this particular expression. I want to find out the root. And by trial and error method, I find out that x equals to 2 is one of the root. So what are the other roots of this particular equation? Does anyone how to find out?
So if x equal to 2 is a root, then x minus 2 will be a factor. Then we divide this whole equation by x minus 2.
So we can divide this whole expression by x minus 2, right? So here we will get the polynomial of a degree 2, right? Here in the quotient of degree 2 we'll get, right? So if I want to, if I differentiate this, sorry, divide this by what factor I have to multiply, that is 2x square, right? So multiply by 2x cube minus 4x square. So if I subtract it, it will be minus 9x square, right? Now if I want, just try to make this coefficient equal and this particular having the same degree. So what I have to do, I just multiply it by minus 9 of x. So just minus 9 of x will be minus 9 of x square minus 2 minus 9 of x plus 18x. So it is plus 22x. So just subtract it. So it will become plus, it will become minus, right? So it get cancelled. It will be 4x minus 8, right? Now just multiply it by plus 4. So here I will get 4x, 2 minus 2 plus 4, it is minus 8. So it will get 0, right? So this is basically my equation, a quadratic equation, and I can simply find out the root of this particular equation. So those root will be my other 2 points, right? So in this way, you can find out the root of this, the polynomial having the degree 3, right? So, okay. So just try to differentiate f of x, right? And equate it to 0, and the root of this particular equation will be my critical point. Okay, anyone, any doubt in this point, in this question? Okay, so now this question number 5. Okay, so what have I discussed? Like, first step is to find out f dash of x equals to 0, find out the roots. Okay, find roots, then do f double dash of x, right? Find out f double dash of x. Now try to put the value of this root, say a, so suppose a, and if it is positive, that is greater than 0, then it will have the minima, right? If it is negative, then it will have the maxima, and if it is equals to 0, then it is a saddle point. No maxima, no minima, right? So what here we have to find out? F of x has a local minimum at x equals to k. Now find the value of that k. So just find out the value of k. It is given to us, it achieves a local minimum at x equals to 4, right? So sorry, at x equals to k. So just try to find out the value of k. I have given the steps, just you have to follow that. Try to answer. If you understand this, then you will be able to solve any problem. Like, it is simple. Yeah. Just you have to differentiate the expression.
Sir, is x equals to half?
Let me see. So what is the differentiation of this f dash of x? Yes,
6x square minus 6x minus 36.
6x square minus 6x minus 36, right? Now we have to equate it to 0. So what are the roots of this equation?
Minus 2 and 3.
6 equals to minus 2 and 3, right? You can simply divide it by 6 here also. So it will be like this: x square minus x minus 6 equals to 0, right? So
Yes.
root of this particular equation will be x equals to minus 2 and 3, right?
So k
Okay.
equal to 3 is the answer.
Okay, let's see. Now I want to find out the local minima at x equals to k, say suppose. So what I have to do, I have to do again differentiate it, right? So what is the differentiation of this particular? Now while calculating the roots, you can divide it by 6, right? So x square minus x equals to 6. This thing you can do. But when we are using this f double dash of x, please make sure that you have to use this expression only, not this one, right? So here we are simply finding out root. That's why we can do like this. But here we are differentiating 2 times, right? So just differentiate this expression. How to? So it will be 12x minus 6, right? So
Yes.
this one double, yeah. Now just put f double dash of minus 2 and f double dash of 3. So what we are getting here? Minus 24 minus 6, that is minus 30. So it is less than 0, means at minus 2, my f of x will have local
Local maximum.
maxima. Yeah. And when f double dash of 3, so 12 into 3 minus 6, it will be 30, right? That is positive. So at x equals to 3, it is having local minima. So we have given x equals to k, so value of k will be 3, right? So answer will be 3. Yes, anyone, any doubt? You have to just follow this 2 simple step, nothing in it. And you should know how to find out the roots. That's it. Anyone, any doubt in this problem? Okay. Now tell me. So now first we'll discuss what is global maximum, global minimum value. What is global maximum, global minimum? Okay, so before that, we'll solve this particular question. So here I have given the closed interval, right? So if I see this graph, I have two local maxima and two local minima here, right? So among all these local maxima, minima, which one is my maximum? So at this particular point B, right? So I can just say this is my global maxima also, right? Among this, but you have to check this is one of the case, and if suppose you are given the closed interval, say a comma b, then you have to find out the value of f of x at a and b also. Now, if the value of f of x at a equals to a f of a or f of b is greater than this particular local maxima, then at this particular point we'll get the maximum value. Okay, so we have to include the boundary points also while calculating the global maxima or minima. So I will come to that example. So this is okay. Let's go through this example only. So I have two function f of x. Okay, so minus x square plus 2x plus 3. Okay, so from x between 0 to 50, and x cube plus 3, that is f minus 50, x 0 to minus 50, right? So yes, tell me. So how to find out the local maxima here? Just focus on local maximum here. Same step you have to follow here also. And these are my boundary points. So this will be 0, 50, and it will be minus 50, 0, open bracket, right? Yes, anyone?
Yes, the solving one.
Okay, yeah. We'll wait for 2 minutes. Okay, just solve for this particular option, whether one is local maximum or minima.
It's one is local maximum.
Okay, so first we have to differentiate it, right?
Yes.
So let's see f dash of x for this particular x, f of x, it will be minus 2x plus 2. And for this f dash of x will be 3x square only, right? Now just equate it to 0. What I am getting? X equals to 1.
One.
And here just equate to 0. What I am getting? X equals to 0, right? Now, whether in order to check whether my points is having local maxima or minima, I have to differentiate again, right? So I'm differentiating this one, this f double dash of x. So it will be -2. So it is negative only, right? Less than 0. So even it is a constant term. Even if I put x equals to 1, it will be still -2, right? So at this point, so I can say at x equals to 1, it will have the local minima, right? So this function is basically x equals to -2, right? So at every point we'll get the local minimum value only. Okay, there is no maximum value for this particular function. Okay, so we'll have only local minimum value. Sorry, local negative. It is local maxima. Sorry, it is local maxima, right? So we don't have local minima value here. Okay, so yes, I can say at x equals to 1 there is a local maxima, right? I just try to put x equals to 0 here. If differentiate 2 times, I will get 6x, right? So if I put x equals to 0 in this function, I will get 0. So that is a saddle point, right? So this is the saddle point. There is no maxima and no minima, right? So yeah, so first option is my correct, right? So 1 is a local maxima because there is no minima value, okay, for this particular f of x. Now what is global minima and global maxima? So what I said, if I given the closed interval, you have to include the boundary points also. So if I put f of x equals to 1 here and f of 0 here, let's see what I will get. So f of 1 for this particular f of x, I will get -1 plus 2 plus 3. So it will be 4. And f of 0 at this particular point, because there is no maximum, so we don't need to put. So f of 1 is giving me this 4, right? So now try to put the boundary points. So what I will get f of 0 in this particular expression, 0 plus 0. So 0 plus 0 plus 3. So that is 3 only, right? Now just put f of 50 here, 50, right? So that is -50 square plus 2 into 50 plus 3. So I don't need to calculate the value because -50 square will be minus 2500, right? So it is a huge negative number. So whole term will be negative only, right? It is less than 4 and 3 already. Okay, so I don't need to find out the value, but I can see it is clearly less than this particular thing. Okay, now check for this point also, that is -50 here. So
Yes,
what
sir,
we are
that will
getting?
be very less.
So if I put -50, so -50 cube plus 3. So it will be less than this also, right? And I think this also. So -50 will have the global minimum value, right? So this two option is correct. Anyone, any doubt how to find out the global minimum and maximum value? You have to check for the interval also, like boundary points also. Okay. Okay. Now try to find out the maximum value. Okay. Now I will not follow the step. Just I will discuss the answer. Just tell me what is the correct answer here. You have to increase the here is, you can see close intervals are there. Okay. It is 0 and 3. Now we have to find out the maximum value. We have the closed interval, so we have to include this value also, 0 and 3. We have to check for this particular value also. Now tell me what is the maximum value here. Okay, I will wait for 3 minutes.
So 5.
Okay, let's see. So at first we have to find out the critical point, right? So for that I need to differentiate it. This f dash of x will be 3x square minus 4x minus 3, right? 3x square minus 4x minus 3. Okay. Now just equate it to 0. What are the roots of this particular f dash of x? What are the roots?
2 plus minus root 13 by 3.
2 plus minus under root 13 by 3,
3.
right? Okay. So 2 plus under root 13 by 3 or 2 minus under root 13 by 3. So everyone knows how to find out the root, right? So we have that formula, x equals to minus b plus minus b square minus 4ac upon twice a, right? So b is minus 4 here, a is 3 here, and c is minus 3. Now just put the value in this particular expression, you will be able to get this, right? So now I have two values. So which value I have to consider? Yes, anyone?
We
You
cannot
can take
take
the
2
interval.
minus root 13 by 3. Yeah.
Yeah, because it is not in my interval, right? It is not in my
Yes.
domain, right? So I cannot consider this value. The only value is this thing, right? So it will be approximately 2 plus like 3 point something. So even it is 5. So divided by 3, it will be in this domain only, right? So I can take this particular point. Okay. Now what we have to do? Find out the maximum value. So this is my critical point, right? In this particular domain. So I have to consider this point. Now, in order to find out maximum or minimum value, just differentiate again this expression, that is double dash of x. It will be 6x minus 4, right? Now just put this in this instead of x. So double dash of a, say I say if it a equals to this, so it will be 6 into 2 plus under root of 13 divided by 3, right? And minus 4. So it will be 2 plus root 13 minus 4. So it will be around 2 plus under root of 13 will be around 3 point something, right? Say 3.5 or 6. Say 5. So I will get 5.5 and say 5.5 and say 11 minus 4. Suppose approximately I'm getting near to 7, right? So just try to find out what is the value of under root 13. Okay. Now this is 7, but I have to check at this particular close interval also, right? So sorry, this is positive, right? This is positive. So it means I have, it is greater than 0. It means I have local maxima, right? So I have checked. Okay, at this particular point, I have local maximum. It is equal to 7, right? It is positive. Now just try to put the value function here and try to find out the value f of x, f of a. So what is the value f of a? You try to convert in this number and just try to calculate using the calculator. This is my calculator.
Sir, like if double dash of x is greater than 0, then it will be local minima, right?
Yeah, local minima, right? If it is greater than 0, it will be local minima. Sorry. So it is local minima, right? But we need to find out the maximum value. So at this point, yeah, correct. At this point, we don't have any local maximum value, right? Hello? Yeah, correct. Are you getting it? So it is greater than 7, so it is having the local minimum value, right? So it at this particular point, it has a local minima. But we need to find out the maximum value. So this is not the point where we'll get the maximum value, right? So now what we have to do, we have to take the boundary points here, right? Now just find out f of 0 and f of 3. At what point we are getting maximum value? It is 5 and it will be 27 minus 2 into 9 minus 3 into 3 plus 5. 18, 9, 27, 27, 27, get cancel 5. So I will get the 5 as the answer, maximum value. Yeah, correct. It will have the local minima because our f double dash of a is greater than 0, right? So we have to find out the maximum value. So then we have to check for the boundary points also.
So here there are two global maximas, right? Like f of 0 is also 5, f of 3 is also 5.
Yeah. But the maximum value is 5 only for both the cases. Okay. Any doubt in this problem? Same step we have to follow. Differentiate f of x equal to 0, find out the critical point, and then differentiate f double dash f of x again. So just try to put those points in this f double dash of x, and if it's less than 0, so it is less than 0, it will have the local less than 0 local maxima, and if it is greater than 0, it is have the local minima, and it is equal to 0, then these are the saddle point. Okay, so no maxima and minima. Okay. Anyone any doubt in this part, maxima and minima?
Sir, if we are considering the boundary points, then we have to take the given equation.
Yeah, directly put the value in the given equation only. Yeah, here. Just directly put the points here and try to find out. Like suppose I have say f equals to 2 here. Okay, so I'll find out the value of f of 2, f of 0, f of 3, and among which it is having the maximum value. That will be my maximum value. Okay.
Okay, sir.
Yeah. So this is about the maxima and minima. Just after this session, you can try to solve the activity question. So you should be able to do all the activity, like at least numerical, all you can do. And for theory questions, you can watch the lecture. But this is enough to solve any question based on maxima and minima. Okay. Now we have one more concept in this week, that is computing the area. So if we know the standard area, we should be able to find out the complex area. Okay. So you should know some area for standard shapes, right? So what is okay? Say what is the area of a circle? Okay, very good. Area of a circle.
Pi r square.
Yeah. So area of circle, that is pi r square. Second square. This is my square. If I have the length a, suppose having length a,
A
it
into
will be
A.
a square, right? So that is a into a, right? Now what is a rectangle? Having length and breadth. So this is my rectangle, length and breadth. So it will be
Length
L
into
into
breadth.
V. Yeah. Now third standard shape is same my triangle. I have a rectangle triangle like this. Like this. This is my edge. This is my base. So what is area of a triangle?
Half base into height.
Yeah. So half
Half
of
into B
base
into
into
H.
half of base into height. So one more is there. Okay. If you know the rectangle, a parabola, parallelogram.
Base
What is
into
the area of? Yeah, same as rectangle, that is length into this particular thing, right? Right? It is h. So length into h. Now, what is the area of? Okay, okay. Last one shape, that is trapezoid. Say suppose I have this is trapezoid, right? This is my A, this is my B, and this is my height h. What is the area of trapezoid?
H into half into A plus B.
Sir, half into A plus B into H.
Yeah. So A plus B into H, right? Upon 2. So this is my area of trapezoid. So these are few standard shapes for which area you should know. Okay. So please remember this point, and based on that we can solve the questions. Okay. So now this is the question. A circle is inscribed in a square S1, and then the smaller square S2 is inscribed in a circle C. Suppose the ratio of the area of square S1 and S2, that is S1 and S2, is given to us, that is m by n. Okay. So and GCD is m S1. So highest common divisor is 1 only. So find the value of m plus n. So common divisor is 1 is means suppose we have say 4 by 8. So I can reduce it to 1 by 2, right? So it is having the common divisor 1. So this is the case. So just tell me what is the value of m plus n. So a circle C is inscribed in a square S1. So we have the square like this. Have the square. This is the square. Circle. Okay, assume it is a circle. So it is a circle. Okay, and then a smaller square S2 is inscribed in this circle C. So this is my S1, this is my C, and again the smaller square is inscribed in a C, and this is my center, right? So this is my S2. This is my S2. So tell me what should be the ratio of S1 by S2? Say suppose I have a radius of this circle as A. Now find out. Just apply the geometry. Just apply the
So is it half?
area
I'm getting
formula.
half.
Half.
Yeah.
How it will be half.
So for the outer rectangle.
Outer S1 will be more, right?
Yeah. So the outer rectangle, the diameter would be the length, and for the inner, I mean, the diagonal would be the diameter for the circle. So I calculated like that. I might have mistaken somewhere, but yeah,
You calculate
that was
right,
the
but
concept.
your ratio, yeah, but it is 2 by 1, right?
Yeah,
Not 1
sorry.
millimeter.
Yeah. That's why I said I might have mistaken something, but yeah, so that was my
Okay.
concept. Yeah.
Yeah, that is correct. So I know this is radius is A, right? From this to this. Then I can also say like from this point to this point. So this is A and this is A. So it is 2A, right?
Yes.
So this is 2A. So the area of S1 will be 2A square. Now what about this particular S2? I have this diagonal, right? So this is my diagonal. This is A and this is also A. So I will write it down here. So this is my 2A, right? And say suppose we have this B. Okay, suppose it is a B. Okay. Now we have to find out the B here, right? Because this is my square, right? It is my square. It is B. It is B. So how to find out the value of B here? In terms of A? Yes, anyone?
Pythagoras, right?
Yeah, Pythagoras theorem, right? So that is B square plus B square equals to hypotenuse square, right? That is 2A square. So basically 4A square. So B square plus B square, it will be twice B square equals to 4A square. So 2 will get cancelled. So I will get B equals to under root of 2A. So this is my length of this particular square. So what is the area of square S2 then? B square, right? If it having the HB, so it will be B square. So it will be root 2A whole square. So it will be 2A square. And here it will be 4A square. So S1 upon S2, that is 4A square upon 2A square will be 2:1, right? So M plus N will be 3, right?
Yes.
Okay, anyone any doubt in this problem? Here you should know the basic geometry and the standard area of those shapes, right? This is activity question. Rest of the questions are similar. You should know the geometry. That's it. Yeah, you can try it out. Okay. Any doubt in this part? Up till now, what I have discussed: maxima, minima, and computing the areas. In computing the areas, you just need to remember the standard shapes and few geometric things you should know, like how to find out the if I know this theta, so how to find out the value of b, right? So that thing I know I have the theta, then that's so geometry, basic trigonometry you should know. Okay. So this is the case. Okay. So up till we have discussed about the local maxima and minima and the computing the areas, which covers the lecture 9.1, 9.2, and 9.3. Okay. So after this session, please try to solve the activity question. Okay. You will be able to solve all the questions. If it is theoretical question, just watch the lecture. Okay. We'll be able to do that. Now, in the lecture 9.4, we are discussing about the Riemann sum integral. Okay. So what is this Riemann sum integral? Let's see. This is my x-axis. This is my y-axis, right? And this is my graph. And say I take this interval A and B. And now I need to find out the area under this curve from A to B, right? So what this Riemann sum integral is telling us, we need to divide this particular area in the small interval and just find out the area of this. So if I divide like this, so this is 1, 2, 3 in the 4 interval. If I find out the area of this particular, then I can simply add the area of 1 plus 2 plus 3 plus 4, right? In order to get the area of under this curve, I can do that if I know the area, right? But how to find out the area of 1, 2, 3, 4? Okay. So for that, if I assume this is a rectangle, it's all as a rectangle, okay? This all are the rectangle. It might be like this or like this also, no issue, right? So I can simply we know the area, how to find out area for this particular rectangle, right? That is length into L into B, right? So if I know this the area of this particular all the 4 intervals, I can simply find out the area between this curve, right? But I need to find out the area of this individual interval, right? So what I can do, I can just take this, okay? This will be my delta x, and I can take any of this height, right? So I can take it this height. Say suppose this is my f of xi, right? So if I know f of xi and delta x, I can find out the area of this particular rectangle, right? And similarly, I can find out the area of this all the rectangle and just sum it. So then I will get the area under this curve. Okay. So are you getting it? What I'm trying to say? Hello, anyone?
So once more, sir, please.
Yeah. So suppose I have this particular curve like this or any curve, and I need to find out the area between this curve from point A to B, right? Under this curve. So I want to find out this area. Okay, this whole area I need to find out, right? So what I can do in order to find out the area, I can simply divide this because it is not a standard curve, right? I can simply
Into
divide this
segments,
into
right?
into different segments like this. So I divide this into 4 segments. Say 1, 2, 3, 4, and I will try to find out the area of this individual thing, right? Then I can simply sum it. I will get the area of this whole curve, right, under from A to B. But how to find out this particular area of this particular thing? Here you can see this will be my rectangle, right? This is my rectangle 1. This is my rectangle 2, right? Now what is the area for rectangle? Length into breadth. So I can see this is my just small delta x, right? It's basically interval. Okay, and this particular height will be my f of x, right? So f of x. So if I multiply delta x into f of x, I will get the area of this particular interval, right?
Yes, sir.
And similarly, I will do this is for delta x1 f1, delta x2 f of x2 plus delta x3 f of x3 plus delta x4 f of x4. Like similarly, I am calculating for all the 4 intervals, and if I sum it, okay, I will get the area of this particular curve. This, okay, this is the basic concept. Okay, but now what this Riemann sum integral is saying? So suppose I have let a and b be an interval. Choose a finite order set of points, including the end points from the interval a to b. So we have chosen the 4 intervals, right? Let x0, x1, x2, xn belong to a comma b. So that is basically now we'll come to that. This is 1 x, this is my y. So this is my curve, this is a, this is b. Now I am dividing this in 4 interval such that a will be x0, is x1, x2, x3 and x4, right? Here you can see x0, x2, xn belongs to closed interval ab, right? Such that x of xi minus 1 is greater than xi. So here you can see xi minus 1 means if I say I equals to 2, so xi minus 1 will be I equals to 1. So 2 is greater than x of 2 is greater than x of 1, right? So this condition is also satisfied. X0 is a, so x of 0 is a and xn is b. So my last interval will be equal to this particular interval, that is b. Okay, so it's called a partition of interval. So I have partitioned this curve in basically 4 segments, four intervals. Okay, so each interval is having the distance, that is x1 minus x0 in this case, right? Here if I find out this particular distance, x2 minus x1, x3 minus x2, and here x4 minus x3, right? So what we are doing in Riemann sum integral, we are just splitting out this particular curve in different intervals, okay, and try to find out the area of individual interval and then sum it. That is Riemann sum integral. Now let f be the curve having the domain to ranges R. We have function defined by some domain. Suppose the interval a comma b is contained in this domain, and let p be the partition of interval a comma b, right? And this is the condition. Now what it's saying, xi star belongs to del of xi and defined as xi minus. Okay, so what is this? I will tell you here. So if you understand what I have discussed just now, I will just take one here. Okay, I am just taking this part alone. I am taking it here. Okay, so this is my curve like this. Okay, so this is my x0, right? And this is my x1, right? Now what I said earlier, I need to find out the area of a rectangle, right? So but okay, so I can take this length as x1 minus x0. Okay, but what length I should take, what height I should take here? I can take this height also, this one, right? This one, I can take this height also. I can take any height between x0 and x1, right? Find out the area between this particular interval. I have graph like this. Okay, hello,
Yes, sir, you're
are you
audible,
get
sir.
yeah, are you getting what I'm trying to say?
Yes, sir, yes, sir, yes, sir.
Yeah, so this is my x0, this is my x1, and if I want to find out the area, say suppose I consider this a rectangle, this is xi minus x0. So I have the width of this particular interval xi minus x0, but what height I should take? Shall I take this x0, this x1, or between any, right? So this is what it is given to us, that is xi star. So xi star belongs to this particular interval, that is xi minus 1 comma xi. So that is xi star belongs to my x0 comma x1. So my xi star will be anything between this particular interval, right?
But it's a closed
And
interval, right?
yeah,
Sorry,
close
yeah,
in
closed interval, right?
close interval, right? Yeah.
Okay.
Yeah. So suppose xi star, and the value of this xi star will be f of xi, right? Xi star. So this will be my height. So I can multiply f of xi star into this difference, right? That is del of x, right? So this del of xi is given to us same thing, x of I minus x of I minus 1. Okay. Now if I sum it for all the intervals, right, I will get the Riemann sum with respect to the above data is defined as. Okay, so this is the Riemann sum. Okay, if I sum all the intervals like this I have discussed earlier, I will get the Riemann sum. Okay, there is a concept of Riemann sum. Now if I just limit it, say suppose I have this interval. Okay, let me erase this part. Okay, so if I have a graph, I am dividing it into different intervals. I'm just finding out the area of each interval, sorry, for each interval and just summing it out, right? So this is basically a Riemann sum integral, right? Hello?
Basically, sir, here we are calculating anti-derivatives, right? That's the thing.
Antiderivative, no, that is not the case. We
I
are
mean,
just
so,
finding out, yeah,
so
the
multiply
area
by
under this
dx, so that's why I said that.
multiplied by,
So like, so delta x, we can write a dx, right? For small intervals.
yeah, okay. So that you can do, yeah. So same thing is here, like for summation, with respect to it, that is defined as this thing, right? Now I can add this interval, say there are n intervals, right? So my I varies from 1 to n here. So this is my Riemann sum integral. Now what is definite integral of function f is here? It's between a to b. If I just put the limit and n tends to infinity, okay? Say suppose I have this particular area between a and b, and I am dividing this in 4 segment basically. Okay, 4 intervals. The larger the intervals, the more the error will be there, right? I will get the approximate value of this area. I will not get the correct value. So if somehow I can reduce this interval, like if I just instead of 4 interval, if there are say 100 intervals, then I will get more accurate answer. Hello?
Yes, sir.
Yeah, I'm getting what I'm to say. Yeah.
Yes, yes.
So what del of x is here? This is b, that is the last point, and it's a divided by number of n. This is basically my del of x here, right? So in this case, if you see, I divide it in 4 intervals. So suppose I have 1 to 5, right? 1 to 5. This is my 1, 2, 3, 4, 5. So b is 5, a is 1, and number of intervals are 4. So I can see 1. So delta of xi, that is distance between each interval is 1 here, right? This is my 1. But if I increase this n, so when n tends to infinity, and this delta xi will become will closer to 0, right? So when this distance will become
Yes.
closer, yeah, this will shift like this here. It will come near to this, right? So I will get more segments, more interval I will get, right? So I will get the more accurate area under this curve, right? So suppose I divide this curve in 4 segments, sorry, 4 interval. But if I am dividing it into 100 interval, by reducing this particular del of xi, I will get more accurate value of area, right?
Yes, sir.
Yeah, so that's what we are doing here. We are limit n tends to infinity, right? So as we are reducing the width of this particular interval, we'll get more accurate value of this area. So now that's what is equals to definite integral. I can simply integrate this curve f of x from b to a, right? With respect to ds, I will get the value of area. So area under this curve, if you want to find out, simply just integrate f of x between b to a, sorry, a to b, anything, and you will get the area. But it is equals to the Riemann sum integral. Okay.
Okay, sir.
Yeah. So this you got, right? So Riemann sum is this one. This is equals to my integral of a to b f of x dx. So f of xi is basically my this height. Okay, this is my f of xi, and del of xi is basically my difference between two intervals, so between two segments, right? And if I calculate area for this for all the interval and just sum it, I will get the area under this curve, right? And if I just reduce the like n tends to infinity, limit n tends to infinity, if I reduce this interval, I will get more accurate value, right? So that is why n tends to infinity here. So this is how I will get the area under this curve. It is equals to the definite integral from a to b f of x dx, right? I hope you understand this concept.
Yes, sir.
Okay. So now one more thing is there, norm of p, right? Let me use different pen. This is called norm of p. That is p like this. We represent like this. So what is norm of p? That is maximum of del of xi. So it is not necessary that I will keep all the interval same. Say 1 1 1. I can say this is say 1. Difference is 1, and I can say this difference is 4 also, right? So I can divide. I can distribute this interval. Like it's not exactly the same thing, right? So I can differently also. But what is maximum xi? Say suppose I have this 1, this is 2, this is 5, this is 7, and this is 8. So difference is 1 here, difference is 3 here, difference is 2 here, and difference is 1 here, right? So the maximum difference, that is maximum del of xi is 3. So my norm p will be 3. So my norm p will be 3 here. That is maximum of del of xi. That's it. Maximum of del of xi, that is my norm p here. Hello, are you getting it?
So it's a maximum width, so you're talking about, right?
Yeah, maximum width, yeah. Because why? Okay, so this thing you understood and this thing you understood, right? It is both are equal. Now see, you can see here limit norm of p tends to 0, s of p, right? So s of p is basically this thing only. So why norm of p is tending to 0? So if I take the maximum del of x, I'm trying to reducing it right to 0. So ultimately, the whatever the value it is less than that, it will also tends to 0, right? So suppose I have 3 by n in this case, and I have 2 by n also, right? If n is tending to infinity, if this term is tending to
It's
0,
tending to 0.
so ultimately all the value which is less than 3 will also tends to 0, right?
Yes, sir.
Yeah. So that's why if maximum is tending to 0, so all the minimum value also tends to 0. So we are reducing the interval, right? So this is what norm of p is there. So this is equals to a definite integral. Okay. Let me discuss one question that will be easier. So it's given to us. Okay. So this is the function f of x equals to x. This partition having the interval 0 to 5. Okay. So it is like this, where xi. So it's our interval is given to us xi, and x0 is like this. Okay. So it is the extension of this. If you just put I equals to 0, 1, 2, 3, you will get this thing. Now I equals to, yeah. So xi is given to us, yeah, xi minus 1. So that is L of xi equals to this thing, right? Now we have to find out the value of this particular using the Riemann sum integral. So 0 to 5 f of x, what is limit n tends to infinity, summation of I equals to 1, where is I to n, f of xi star into del of xi, right? Okay. So if any one of you know the integral, what is the integral of x here? 0 to 5.
Sir, x square by 2.
X square by 2, and this we have to put the value, right? So it is 5. So it will be 25 by 2, right? Definite integral. So our answer should be 25 by 2, right? By this calculating this, right? Now let's see what is our answer. So now it is del I xi here first. Difference between xi minus 1. So if you take this as xi minus 1, this is xi, or any two term individual term, or here you can also put. So difference will be del of xi equals to, say I put 3 into 5n, and 1 will be 2, right? So 2 5 by n. So you can put any number, so you will get the difference ultimately 5 by n only, right? So my del of xi is 5 by n, right? Here you can see 5 by n minus 0, 5 by n. 3 5 by n minus 2 is 5 by n only, right? So this is del of xi is 5 by n. So that is my given to me, right? Now what is f of xi star? What is xi star is given to us? Xi. So xi star is equals to xi, right? Now what is xi here? Here you can see I into 5 by n, right? Now just put integral of summation of I varies 1 to n, limit n tends to infinity. What is f of xi star? F is given to me x, right? Xi star will be this thing, particular value. So that is I into 5n, right? This is my f of xi. What is del of xi? That is 5n, right? Here you can see that is 5n. Hello, are you getting it? What I'm doing?
Yes, yes.
Yeah. Simply, I have this Riemann sum integral formula. I have to calculate the integral this. I know this is a Riemann sum integral, but I need to find out del of xi star and del of xi first. So del of xi is given to me, that is xi minus I minus 1, right? So that is the same thing. So if you just put xi minus xi minus 1 5 by n, you will get 5 by n only, right? That is my del of xi. Now just what is xi star, f of xi star? Instead of x, we have to put xi star. Now what is xi star is given to us? That is xi. Now what is xi? That is I5 into n, I5 upon n, right? Just put here, just simply put here. So this is I into 5 by n into 5 by n. So what I will get? Limit n tends to infinity, summation of I equals to is n, right? So it will be 25 I n square, right? So now tell me, what is this 25 I n square? 25 n is a constant term, right? I can take it outside the summation. The summation of I varies from 1 to n I.
That's
So
n
it is
into n
given
plus
to us.
1 by 2.
Yeah, it is given to us, right? This is hint. So what does this mean?
It's the
I
summation
equals
of
to 1.
natural numbers, sir.
Yeah. So just when I equals to 1, just till n, right? 3 plus like this till n. This is what it is. And here, what is summation of natural number will be? N into n plus 1 by 2. It is given to us, right? So instead of this, I can write this, right? So that is 25 n square into n plus 1 by 2, right? So this n, this square will get cancelled. That is 25 by 2 n plus 1 by n. But we have this limit, so with this we calculate, right? So we have this limit n tends to infinity. So it is equals to limit n tends to infinity 25 by 2. What is this limit? Yes, anyone tell me?
1. I mean, n plus 1 by n
1.
is, yeah, 1.
Yeah. So limit n tends to infinity. This is constant term. I can take it outside, right? So
Yes.
if I take it, it's 1 plus 1 by n. If I put, it will tends to 0, right? So it is
That's
1
1.
only. So we get 25 by 2 as an answer, right? So this is how we apply the Riemann sum integral. In general, if you want to find out the area under any curve, we just simply integrate it, right? That is the thing we do. But here we are learning Riemann sum integral. That's how definite integral. Okay. That is, any doubt in this part? I know it is little complex, but if you just go through the content or just solve any question, then it will be. Any doubt in this part?
No, sir.
Yeah. Nothing need. We are simply dividing the area under curve in and intervals. We are trying to find out the area for each interval, and we are just summing it out. That's how we'll get the area, right? Same thing we are doing here. So this is the Riemann sum integral. Okay. So
No,
this
sir.
is all in the yes,
Sir, can you explain once again this norm P thing?
norm P. Okay. So norm P means, say suppose I have this curve like this. I have this interval A to B, right? Say A to
Right.
B means say 1 to say 10. Okay.
Okay.
I am dividing this curve in different intervals, not equal intervals. So different interval means, so previously I have divided this into interval of 1 1 1. Say distance between two sub intervals is 1 only, right? It is
Yeah,
constant.
yeah.
But here what I am doing, it is 1, say it is 2, it is 5, it is 8, it is 10. So difference between these two is 1.
Yeah.
Difference between this del of x, del of x is here 3.
Yeah.
Here del of x is also 3, right?
Yes.
Here
Yes.
del of x is 2. So del of
Yes.
x is 2. So the what is
Yes.
norm P here? That is maximum of del of xi. This maximum of del of xi. So del of xi maximum is here 3, right?
3, 3,
The
3.
norm
Yes.
of this particular curve from interval A to B is 3. It is maximum del of xi. That's it.
Okay. 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 Okay.
Yeah.
Got it. Thank you.
So if you are trying to limit norm tends to 0, means if you are trying to reducing this 3 to 0, this interval to 0, because ultimately we are reducing this 2 and 1 also it to 0, right? It will also get reduced. So that's why we take the maximum del of xi. So suppose if we take this 2 instead of 3, not the maximum one, but this 2 will tends to 0 here, but not the 3, right? So that's why we always take the maximum del of xi and it will tends to 0. We are trying to reduce the interval so we can get a more accurate result. So, hello? Abhinav, you got it, right? What is norm of
Yeah.
P?
Got it, sir. Got it. Thank you.
Okay. Okay. Great. So this is in the lecture, I guess, in the 9.6, this Riemann sum integral. Now these are some standard derivative and integral you should know. So just you can go through it once, right? So it is cosec x square, right? Minus into cosec x into tan x square. It is also not correct. So just go through this slide, okay? Function. What is this derivative? What is this integral? This is a function. This is derivative. This is integral. Just go through this slide once, okay? And this is some basic properties of definite integral. If we have the constant, we can take it outside the integral. If there is summation, we can transfer this integral to individual term. Same for subtraction, right? And this is say suppose I have a integral from b to a, so a to b, so write this. So I can change it to a to b by just putting the negative sign, right? This thing I can do. This is one of the thing. Then for any c belongs to r. Yeah, so suppose I have integral say 1 to 4 f of x, and I can write it down as 1 to 2 f of x plus 2 to 4 f of x dx. So this is what this rule is, right? I can split this into integral also like this 1 to 2 and 2 to 4. Just one charger. And if f of is greater than this g of x, but all finally many points of interval a and b, then this integral will always be greater than this. Okay, these are the few rules, and these are some standard derivative integrals. Please go through it and remember it. Okay, it will be useful. Now, there's one more concept. So suppose there's one more rule. So I have integral from minus a to a f of x, right? Dx. Same limited from minus a to a. But if my f of x is even function, means if I replace x by minus x, I am getting f of x only, then this integral will be at minus a to a f of x dx will be equals to twice of 0 to a f of x dx, right? For even function. If my f of x is odd function,
Will be 0,
that
right?
is, yeah, that is minus of x, that is minus f of x, then in that case minus a to a f of x dx is equals to 0 directly. For odd function it is 0, and for even function it is twice of this particular function, and it will vary from 0 to a, right? So please note this point. If it is minus a to a f of x dx, just check whether it is even or odd function. If it is even, just twice of it, or if it's odd function, it will be 0. Right? So how it came? You can follow this particular property, right? So I can write it down like this also, like integral minus a to 0 f of x dx plus 0 to a f of x dx, right? So if it is odd function, it will be equal. So I can just cancel it out. It will be equals to 0. And if it is even function, it will be equal. So just plus it will be twice of this particular function. So this is how it's like it is derived. But just remember this thing. If we have this particular integral from minus a to a f of x, if f of x is an even function, it will be a twice of 0 to a f of x dx. And if f of x is odd function, it will be equals to 0. This simple thing. Now just try to find out this value of a. Tell me what is the value of this particular integral. So we have minus a to a here, right? Minus 2021 to 2021. So just check whether my f of x is even or odd. If it is even, then just simply try the twice of this, and if it is odd, it is directly 0. First, see whether it is even or odd function.
Yes, sir, it is odd, I guess. Yeah.
It is odd function, right? So how to check it? So
Just
this
put
is my,
x as minus
yeah,
x.
this is my f of x, that is cos of 2021x sine of 2021x, right? Now just replace x by minus x here. What I will get? Minus x of 2021 cos of 2021 minus x plus sine of 2021 minus x. So you must be know that cos of minus x equals to cos x, right? And
Yes,
sine of minus x equals to minus sine.
minus sin x.
Yeah. So like in Hindi you used to say like this: cos minus को खा जाता है, sin minus को बाहर फेंक देता है, right? So this is how you do. Now you can see here this is an odd power, right? It is an odd power, right? So it will be negative only, right?
Yes.
Yeah. So this is cos 2021 x, right? And plus the minus sign will come this outside. So minus sine of 2021 x. Now I can take minus common. So it will be x of 0 2021 into cos of this plus sine of 0 21x. So this is basically my f of x. So if you replace x by minus x and you are getting minus f of x, then my function is f of x is odd, right? And if it is odd function, we have like this from minus a to a, we can directly say it is a 0. integral is 0. Okay. Anyone, any doubt in this part? So whenever you see such type of integral, just keep this thing in mind. Okay, you need to apply that. Okay. Now this is another activity question based on the curve area. So we have f1 of x and this one is f2, right? So this one is f1 and this one is f2, right? Represent two curve if A is the area which is enclosed by f1 of x and f2 of x, and find out the value of 3a. So we have to find out this area, right? How to find out this area? I can find out the area under this curve from this point to this point, and then I can subtract this area, right? Then area under this curve.
Yes.
I will get this area enclosed by this, right? But what are those points? At first, I need to find out. So I have to how to find out this point? These are the intersection point of these two curves, right? So how to find out intersection point? Yes, tell me anyone. What are the intersection point here?
Equaling both f1 and f2.
Yeah. So f1 of x equals to f2 of x. So it will be 3x square. It will be 4 minus x square. So 4x square equals to 4. So x square equals to 1. So x equals to plus minus 1, right? Now when x equals to 1, but y coordinate will be 3. And when my x equals to minus 1, then still my y coordinate will be 3 only. So this will be 1 comma 3 and it will be minus 1 comma 3, right? Now I need to find out the area of this thing, right? Under this curve from minus 1 to 1. How to find out? These are my intersection
We can
point.
take the integral.
Yeah, we can simply take the integral.
4 minus x square.
Yeah, of f2, right? So I
Yes.
have to take integral of f2 of x between which limit? Interval?
Minus 1 and 1.
Minus
Minus
1
1 to 1. Yeah, minus 1 to 1. So that is minus 1 to 1, 4 minus x square. Now what is the integral of this? Yes, anyone tell me? We have just discussed one question which is having minus a to a. See now, same thing, right? We can apply here.
It would be like 0 to
4x minus x cubed by 3.
0 to 1, 4
0,
minus x
4
square.
minus x
Because
square.
it is the even function, right?
Even function.
If I
Yes.
replace x by minus x, I will get f of x only. So it will be 4x minus x cubed by 3. That is twice. So
Yeah,
0 to 1. Just put the value here. So twice of 4 minus 1 by 3. Right? So 2, 12 minus 1, 11 by 3. So that is 22 by 3. This is my area for f1. Sorry, f1, right? Sorry, f2. Area of f2. Now this is my area under this particular thing. Now I need to subtract this area also, right? Area under this curve. This one. For that, I need to find out the area under this curve f1 also, right? So let us find out area under this curve f1. So it will be minus 1 to 1 again, f1 of x. So minus 1 to 1, 3x square. So it is again an even function, right?
Even function.
Yeah, so I can write it as 0 to 1, 3x square. So it will be 3x cubed by 3. Yeah, so 0 to 1. So 3 will get cancelled. So 2 by 3 will be the answer. Right? 2 by 3, correct? Yeah.
Yes, sir.
Now the area under this curve will be F2 minus F1. Area under F2, that is this, right? Minus this. I will get this curve, right? So it will be 22 minus 3
How is it
upon
2 by
2 by
3? It's 2, right?
oh yeah, 3 will get cancelled.
Two.
2 only. So this is still getting cancelled. It is 2 only, right? Yeah. So it will be 2. Now just subtract it. What I am getting? 16 by 3, right? Now we have to find out the value of 3a. This is my area under this curve. Now 3a will be 16, right? So the answer to this question will be 16. So at first you need to find out the intersection point and then just find out the area under this curve, okay, using the integral. That's it. Okay, anyone, any doubt?
No, sir. I mean, for this question.
Okay. So this thing you can try. This is more simpler. Okay. Just try to find out the value of this integral. But for that you should know the standard integral, right? It is given to, hint is given to you. The integral of xn is xn plus 1 upon n plus 1 and integral of 1 by x is log of x. So what is the value? What is the correct answer? Yes, anyone? Tell me. Okay.
So it's C, sir.
C, right?
Yeah.
So if I integral this 3 into x cubed by 3, right? Minus 1 upon x, that is integral of 1 upon x is ln of x, right? And plus constant of integration, that is c. And this is 1 to 2, right? If I put 1 to 2, so 3 will get cancelled, right? So x cube minus ln from 1 to 2, so it will be 8 minus 1 plus, sorry,
So 8 ln
minus,
2. 8 minus.
yeah,
Oh,
I'm
oh,
putting, okay,
you're just
that
combining.
thing,
You're just
yeah,
combining
yeah,
values. Okay, okay.
combining it, yeah. So ln of 2 minus ln of 1, right? So it is 7, sorry.
Yes, sir, you're right. There's no answer in 4 options
Yeah,
here.
it should be some minus.
7 minus ln.
Minus
Yeah.
7 minus ln 2, right?
So,
Minus is not there. Oh, wait, it is a plus. Sorry. This is plus, this is plus, this is plus, this is plus, this is plus. So answer C is correct. Okay, any doubt? It is plus here. Sorry, I didn't find out. Okay, now it is correct, right? 7 plus ln of 2.
yeah, yeah. Yes, sir. Now it is.
So this is how we evaluate definite integral if we know the standard integral, right? And using these properties. So now there is something called integration by substitution. So suppose we have to evaluate integral of this f of g of x such that whose derivative is given to us like this, g dash of x, right? Then we can use the substitution method. Like we can simply substitute gx equals to u, differentiate g dash of x dx by du, right? And then we can simply put instead of g dash of dx, it is du and f of u, right? So it will become like this. Okay, and then we can simply evaluate this particular integral. Okay, and then we have to resubstitute it u equals to g of x in the final expression. So let me take one example. Say f of x equals to say 2x into sine of x square plus 1 and dx. Okay, now you have to evaluate this integral using substitution method. So what substitution you have to do here? Such that you have to see whether which is the derivative I am getting here. If I put say anything equals to say g of x equals to d, that g dash of x should be there in my f of x. Okay. Yes, anyone? So which substitute I have to put here in this
X square
case?
plus 1 equals to t.
Why?
Because differentiation of that is 2x and it is given.
Yeah. So 2x already given to me. That is so I can simply differentiate 2x with respect to x, right? 2x dx equals to dt. So I can replace this 2x dx by dt and x square plus 1 by t. So what I will get? Sine of t dt. So what is the integral of sine?
Minus cos.
Minus cos of t. Now we have to resubstitute it, right? So
Yes.
it will be minus cos of x square plus
Plus
1.
c.
So this is the answer for this particular
Plus c.
integral. Plus c, constant of integration, yeah. So you can use this substitution if we know this. Okay, if we substitute that particular derivative exists in this particular expression, okay, then only we can use the substitution method. So let us take one more complex example. Now tell me here by how to solve this, which substitute I have to use. Whose derivative should be there in my expression. Just tell me which substitution I should put.
And root
Should
x is equal to t.
Sir, t equals to root x.
root x equals to 2. What is the derivative? If I differentiate with respect to x.
Sir, 1 by 2 root x.
So do we have that? I can do like this also, right? Divide and multiply by 2. Hello.
Yes, sir, we can do
Yes.
that.
Okay.
Derivative
So
of tan x equal to secant square.
yes. That substitution also we can do here. So first thing is that if we put root x equals to t, or second thing is that tan of root x equals to t, right? Now let's see both the case. Now here I will get 1 upon 2 root x dx equals to dt, right? So if I replace here, what I will get? Multiply by and divide by 2. So 2 root x dx will be equals to dt. So twice, and root x equals to t. So twice of tan 4t into sec square t into dt, right? Now can we evaluate this integral directly? This thing? Because again we have to put substitution here, like tan of t equals to u and say sec square t equals to du. Sorry, dt equals to du. Right. Are you getting it what I'm saying? We cannot
Yes, sir,
evaluate
yes,
this
sir.
integral directly. We have to again substitute it like tan of t equals to u and sec square t and dt equals to du. So if I replace this term by du and tan t by u, so I will get twice of u to the power 4 du, right? This is my final I will get. But if I replace this, if I substitute tan root of t equals to t initially only, so it will be sec square root x, right? And again this derivative of this root x, right? By chain composite rule, 1 upon 2 root x dx equals to dt. So sec square root x dx. So instead of this, I can use this, right? I can put dt here. So I will get twice of t to the power 4 dt, right? Same thing, right? This variable we are changing because we are substituted. Same expression we are getting. So you have to see like which substitute you have to do. You can do like this also, root x equals to t, but again you have to put again another substitution here in order to solve this integral.
We can
Yes,
we can also put tan root x as t, right?
tan root x equals to t. So what is the derivative of tan root x? Yeah, that's why we're putting na tan root x equals to t here. Either we
So
can
this
put
is
root x equals to t. Yeah,
this is double substitution. Here we can do it directly, right?
directly. Yeah, just simply put tan root x equals to t. So that's how we have to see. Like if I substitute say instead of g of x, so the g dash of x should be there, right? So either you can do like this or like this also, both are correct, but again you have to do the substitution here, sorry, again substitution here. So it depends on the question, you may think about it, right? So no issue in that. So in both the cases, we'll get the same answer. Okay. So I will not evaluate this, like it is simply 2 into 5, right? Now resubstitute it. Instead of t, just put tan of root x, that is 5, and that is 5. That is the answer. That's it. Okay, anyone any doubt in this problem? Integration by substitution. You just have to think like which substitute you have to put here, such that the derivative should be there in my f of x. Right? You can add or multiply any constant. You can divide or multiply any constant so that you can make it put a substitution. That thing you can do. Okay, any doubt in this integration by substitution part?
No, sir.
Okay, try to solve. Here hint is already given to you. X equals to u. So it is simpler, right? So just put 3x equals to u. 3 dx equals to du. So we have dx. So instead of dx, I have to put du by 3, right?
Sir, option B.
Yeah. So it is du by 3. So it is u by 3 and u is again. Yeah. So it is option 3 is correct. Like everyone get it. Why I'm dividing it by 3? Because 3 of dx equals to du. But here we don't. We have dx only, right? So instead of dx, I can put du by 3. Or you can do like this, divide or multiply by 3, and that instead of 3 dx, you can put du. Same thing. Right? So you just need to think like in this case, which substitution you have to use. That's it. And the integration, you should know standard integration. Now this is the last part of this week, that integration by part. So here, if we want to evaluate this integral, say f of x into g of x, so what we have to do, say take it, this is the first function and this is the second function, right? So keep the first function as it is, integrate the second function minus in integral derivative of the first function into integral of second function. So this thing you have to keep in mind, this particular integration by parts. So first function into integral of second function minus in another integral derivative of first function into integral of second function. Okay, here you can see, or we can write the same thing, but here you should we will follow this. This is general convention. So integral of keep the first function as it is, integrate the second function minus in integral derivative of first function, integrate the second function. Now which one to choose first function, which one to choose second function, that we will decide based on one rule, that is ILATE, I-L-A-T-E. So I stand for inverse trigonometric function. So whichever come first, we will take as the first function. L stand for logarithmic function. A stand for algebraic function. T stand for trigonometric function. And E stand for exponential function. Exponential function. Okay. Okay. Now let us take one example. Suppose I want to evaluate the integral of log of x, ln of x. What is the integral of ln of x? Yes, anyone?
Sir, lnx, right? Like, what are you asking?
Integral of ln of x dx.
It's 1 by x.
No.
That's differentiation.
Oh, that's very.
Yeah. ln of x dx. Tell me. We need to find out the integration of ln of x, but can we
And we can
apply
take it as
integration by
1 into lnx, right?
yeah. So if there is nothing, there is 1, right? So I can write it as 1 into ln of x also. Now, which one to take the first function? Which one to take the second function? Based on
lnx
ILATE
will be
rule?
first.
Sorry?
lnx will be first, right?
Yeah, because logarithmic is coming first and algebraic is after that, right? So we'll take logarithmic function as a first function. So just apply this integration by parts. Just put the first function as it is, integrate the second function, that is 1 with respect to dx, minus integral of derivative of first function. Now what derivative of first ln of x, that is 1 by x, right? Right, into integral of second function, that is 1 dx. So here ln of x into integration of 1 is x, minus integration of 1 by x into integration of 1 is x. So this x will get cancelled. So what I will get, x ln of x minus integral of 1 dx. So x ln of x minus x. So integration of ln of x equals to x ln of x minus x. This is the integral. Hello, are you getting it what I am doing here? I
Yes.
just assume there is 1 because this nothing means there is 1. I can take it as a second function because it's algebraic function we can consider, and logarithmic is the first term, right? So just take the first function, integral of second function minus in another integral derivative of first function into integral of second function, right? And then this evaluate the integral again. So that's how we do. Now there are this activity question. There are two functions. Okay, so try to solve this ln of x, same thing dx. So which one is first function, which one is second function? You should tell me and try to find out. I let.
First function will be lnx.
Because yeah, a logarithm is coming first, right? After that algebraic, right? So we can consider this as a first function and this one is as a second function. So keep the first function as it is, integrate the second function minus in another integral, so it is respect to dx. So in another integral, derivative of first function, that is ln of x, that is 1 by x into integral of second function, that is x cube dx. So ln of x minus, into x4 by 4 minus into integral 1 upon x into integral of this, that is x4 by 4. So it will get 3. Again just apply. So this will be as it is, ln of x by 4 into x to the power 4 minus integral of x cube by 4, right? That is ln of x by 4 into x to the power 4. Then I will get 4 upon 16, right? Right? Yes. So correct option will be option B, right? If I multiply x4 here, so I will get y plus is coming. It is plus, sorry. So option B is correct, right? Hello, anyone, any doubt in this part? This is integral by substitution. You need to choose whether which one is the first function, which one is the second function. Okay, can you try for this particular function?
How is
Tell
plus
me
coming?
There should be minus in
Minus,
between.
yeah.
minus, right?
It means A and
Yeah.
B both are wrong.
Yeah,
Right?
yeah, both the quotient. Okay, it is right. So negative sign will not come. So yeah, this is not correct because we don't have 4 here. So here it should be minus, right? Then it is correct. Which one, which activity is this? Let me check.
Sir, what is the integration of a to the power x?
A to the power x is a to the power x upon log a. Is given in the here where it is a to the power x upon log a. Derivative is a to the power into log a, but integral is e to the power x upon log a. So just try to find out this. I will check which activity question is this. Yes, correct. In the portal it is updated. Yeah, it is. If it is minus, then it is will be a correct answer. Now just try to evaluate this function, integral of this. So which one is the first function? Which one is second function? Here, just anyone.
X square will be the first function. 2 power x will be the second, as it is exponential.
Right. So a is coming first. So a will be the first function, right? So let us try to solve it. Integral of x square to x and dx. First function is x square. Second function is like this. Keep the first function as it is. Integrate the second function minus integral derivative of first function, that is 2x, and integral of the second function, that is 2 to the power x dx. Let's see. So here I will get what is integral of 2x, that is 2 to the power x upon log of 2 minus 2x into to the power x upon log of 2, right? So I will get 2 into 2 to the power x of log of 2 minus 2 log 2 constant, right? Again minus integral of x into 2 to the power x. So again we have to apply integration by parts here, right? For this case, this is not minus, this is into. This is minus. Hello?
So that is natural log you're taking, right?
That is natural log only, yeah. So again we have to apply this rule, right? So
It will be x square, right? X square into 2 power x by log 2.
here in this term,
Where's the
Second
point?
step, sir.
seconds, it is x, yeah.
Third step also, I mean, everywhere.
Yeah. Sorry. It's x square. I just skipped the x. Okay. So what is now again I have to apply, right? So same first function, this is second function. So keep the first function as it, integrate the second function. I'm directly doing it now. Log of 2 minus derivative of first function, that is 1, integral of second function, that is 2x log 2. So it will be x 2x log 2 minus 2x. Again log n will come, right? So multiplied by 1 by log n. Sorry, log n of 2. So now just try to combine all this thing, what I will get. I need to simplify it, right? So first term is x square. First term is x square 2 to the power x upon ln of 2 minus of twice of ln of 2, right, into x into the power ln of 2 minus to the power x ln of 2 square. All right. So this will be the correct answer, right? So this is the first term. If I multiply 2 by ln into this, so I will get x into ln square, right? Yeah, so 2 here, so 2 into to the power x means I can write to the power x plus 1, right?
Yes.
This one here, yeah, so this is the case. And the same thing here we are doing. So it is square, so if you multiply by ln of 2, it will be cube, right? So minus minus will become plus. So option C is the correct one. Okay, any doubt in this part? Anyone? Just try to solve after this session, okay, by your own. Here I am solving, so you might think it is easy to simplify, but you can try it out. Now this is the last question. Now which one is the first function? Which one is the second function? Tell me.
The sin x will be
Sin
first
x is
function.
the first function, e power x is second function.
Yeah. So what is this integral? Keep the first function as it is. Keep the first function as it is.
Sin
Integrate
x,
the second function minus an
power
integral
x.
derivative of sin x, that is cos x, and integrate the second function, that is e to the power x. So it will be sin x into e to the power x minus to the power x into cos x, right? So again we have to apply integration by part here. Same thing, it will be first function, it will be second function, right? So sin x e to the power x minus bracket I'm writing. So first function is my which function? Yeah, cos function. So cos x into integral of e to the power x is e to the power x only, minus in integral derivative of cos x is minus sin of x, and integral of e to the power x only, right? So just simplifying it, sin of x into e to the power x minus e to the power x into cos of x plus, this is not an integral, this is a bracket, right? Plus integral of e to the power x into sin x. Okay, that is dx. So again, you can say I'm getting the same integral, right? If I keep applying the integration by parts, I will not reach any, I will get the same term again and again, right? So in this case, what should we do? This is bracket, okay, this is bracket, this is integral, this is the bracket, and this is my integral. Now tell me, what should we do? Because if we keep applying this integration
Sir,
by
take
substitution,
ax sin x equals to I.
okay. So let us say let I equals to this thing, right? So now, so I equals to sin x ex minus ex cos x. This minus will become, right? The plus will become minus ex sin x dx, right? Now I can replace this by I, right?
Yes.
Same term. So what I will get? Sin x ex minus ex cos x minus I. Okay. Here it's also I. So minus I will go on this side. It will become twice I. Sin of ex into e to the power x cos x. Right? Sorry, it is minus. Right.
So sin x into e power x.
Yeah. So sin x into e to the power x minus e to the power x into cos x, right? Now from this I can say I equals to e to the power x common sin x minus cos x divided by 2, right?
Yes.
Because twice I is there. So this will be my integration of this particular term. So don't worry, we'll not ask such type of question in the quiz or end term. Like I'm talking about this particular case where we need to go on this side I. So this is how we apply the integration by integration by parts. Sorry, yeah. So if we're getting the same term again and again, we just simply assume it as a I, okay, and then we can put we can do like this. Okay, anyone any doubt? Then I covered almost all the part. So I know this Riemann sum is little bit complex. So try to watch the lecture and just try to solve it. But I think the most of the activity question you can solve now. Okay, anyone any doubt? Okay, so just try to watch the lecture content. Okay, solve the activity question. So I think today's session will be enough to solve the activity question. Okay, so just watch the lecture and then solve the activity question. Okay. Okay, thank you
So
then.
Thank you.
Yeah.
Thank you very much, sir. Have a good day. Nice day. Bye.
Thank you. Bye bye. Good day.